Hi friends, welcome to follow up. In this video, we are going to analyze problem 452, minimum number of arrows to burst balloons. This problem actually is yesterday's daily challenge problem. So here we postponed today because I'm coughing yesterday, so it's not easy to record new videos. So in this problem actually is marked medium by leetcode. Actually, if you know the interval merge type problems, then this problem will be rather straightforward. So overall, I will categorize this one. So its type is an interval merge type problem. So what we are going to do, the strategy to solve this problem. So there's two ingredients. One is sort. Second is linear scan. As you can see, because here we are using linear scan, so the main term complexity is using in sort, but the linear scan contains the main problem logic together with sorting. So we are going to first look at the problem statement, and then we look at the constraint, and then we're going to give a quick walkthrough of how to do it in an efficient way. So here we have some balloons. It's represented by a point or interval, so you can see. So you have x start and x end. So this is the horizontal diameter span, right? So arrows can be shot up directly vertically in the positive y direction from different points along the x-axis. So a balloon in this closed interval with x start and x end is burst by an arrow if x is in between this two endpoints, inclusive both ends. So there's no limit to the number of arrows that can be shot. A short arrow keep traveling up indefinitely, bursting any balloons in this path. So this is actually very important, right? So as long as you have overlap, if you use the the common coordinates, so then you will burn both or all. So here, given the array points, we want to return the minimum number of arrows that must be shot to burst all the balloons. So let's quickly look at these examples. So here, this example 1 basically tells us, so the balloons are not necessarily in sorted order, right? So if we look at example 1, so the point, if we sort it according to the first coordinate, so we are going to have 1 6 2 8, I guess, and 7 12. And also we have 10, 16, right? So if you look at the first two intervals, so they have overlap. The common part is 2 to 8, right? So we have 2 to 6. This is the common part. So for this two, we just need to shoot any balloon in between 2 and 6, right? But if you look at 7 and 12, so this group represented by 2 and 6 does not overlap with the balloon represented by 7 and 12. So this need 1, right? 1 shot. But this need another one. But if you continue to do the scan, you see 10 and 16. So it has overlap with 7 and 12. So the overlap is nothing but 10 and 12. So in other words, in order to cover these two balloons, we just need to shoot a balloon for any x in between 10 and 12 for integers, right? So that's another one. So in total, we need 2. This is the example 1. So example 2 is very special because it's already in sorted order. If you look at the first coordinate, and then all these 4 intervals are non-overlapping. Therefore, we need 4 shots for each interval or each balloon. So this is the example 2. So if you look at example 3, So things become interesting, right? So let me copy this one here. This is also in sorted order, but there are some overlaps. So if you look at the first two, so they overlap at the point 2. So if you shoot a balloon at point 2, you can kill these two balloons. So 1, 2, and 2, 3. So we're going to shoot at 2, 2. You can use this one to represent this single point, right? Then we can continue. So we have 3 and 4. Those 3 and 4 have overlap, has overlap with this one, but this is already shoot, so we can start again another shoot. So this one has overlap with 4, 5 in the same fashion as 1, 2, and 2, 3. So we have 4 and 4. So we need another one. So this one shot, this one shot. So in total, we need 2, right? So this is also our plan. So first we are going to sort according to the first coordinate. So you can also order the second component, but that is not essential. Secondly, do linear scan, right? So if we can merge several intervals, so in this problem here, so we do basically, if we think of intervals, actually we do intersection, right? For example, here you see 1, 6, and 2, 8. We want to shot a balloon in between 2 and 6, right? This is the intersection. So with that said, let me quickly write a code, and then we can digest that again. So first, I'm going to change this points to be a p, right? This is for convenience. And then I'm going to sort. So here I just use the natural order, but if you want to specify, you can add a k. For example, k equals lambda, so atom. So I sort according to atom naught, right? The first component. But it's in effect, you can omit this part. So this is the first step, actually. Let me do something like this. Step 1, sort. And then what we are going to do is, for convenience, so we do linear scan, right? So I can first get the length of this number of balloons or intervals. And then we can, because the length of this point is at least 1, right? So we can initialize a result variable by 1, meaning that we need at least one shot to shoot the balloon starting at point 0. So also we forgot to analyze the constraint. So here the length is bounded above by 10 to the power 5. So this basically give us a problem size upper bound, right? So here x start and x end is assigned 32 bit. I guess. Oh, okay. So let's see. It's signed 32 bits integer. So here we can have a start and end. So it's the p0, right? So for example, you can think of this p0 as a start and end as 1/6, right? Then we are going to do linear scan. So for I in range, so from 1 to n. So we look at the current interval, pi, right? So we consider their relations to see if they have overlap. So if s is greater than n strictly, so there's no intersection. It means that so this start and end should have at least a balloon. So we are going to increment the result by 1. And then we are going to reset the start and end. So start will be the current start, right? Because we have sorted start. So start will be always larger. So end will be the minimum of so, but in this case, because this end is or must be So this e must be larger than end, which is just a new one, s and e, right? So that's the one case. Another case is that this has overlap, so we're going to set start and end to be s. So s is always greater than or equal to a start, because start is in sorted order, right? We sorted according to the start. And then the end, because we are computing intersection, we're going to compute the mean of the previous end and the current end. So it's possible that this e is less than end, or equal to end, or larger than end. Both all three cases are possible. So after this, we just need to return the result state. So this actually forms one solution format. So before any comments, let me first run this code. Yeah, it passes one example. So now let's look at the generic case. Yeah, it passes all the cases. So if you look at this problem, you can actually also look at its similar problems, right? So non-overlapping intervals, you can try this problem, same idea. But this one maybe is a little bit extension, or can be regarded as a small extension, because here we compute the mean. So to recap, so here the main part is sort and then do linear scan. So actually, if you try to modify this code, you can also print out those things. For example, let me copy this part. And so we can basically determine where we should shoot the balloons or shoot the arrows. So we can use an auxiliary, so as a list. So in this case, if we increment the result by 1, so we can do aux append. So press start and end, right? So I guess when I equals n minus 1, we need to also consider this case. So if n equals not n, I equals n minus 1, so after you reset, we need to aux append, so start and end. So let's see. If we run this, we can print out this part. Print aux. So let's see. For this example, if you check that, so we need 2 balloons. So we can shoot the balloon. So choose an x in between 2 and 6, and choose another one in between 10 and 12. So this is the example 1. So now if you look at example 2, there'll be something like this. So you choose one in between 1 and 2, right? Another in between 3 and 4. I guess this problem is a little bit problematic. So here also, if I equals n minus 1, so you need to do append this start and end. Let's check again. Yeah, you will have this 4, right? So if you look at this one, so this is the intersection, 2, 2, and 4, 4. You can put it here, right? So this actually, this version is just to give you some more information if you want to get all those places where we should shoot the balloon. So in the first one, you notice that if we have already sorted according to the first interval, we don't actually need to use this start, right? Let's maybe simplify it a little bit. So let me copy this part. So I'm going to change this one to be version v1. This one, some more information, so revision, right? So now let's look at this one. So we can just or we can just use end equals p1, right? Then we don't need we don't need to have this s even. So here we need so we have s. If s is greater than end, so we have this one, and then we just set end to be the current end. And otherwise, we just use s. We just need end to be the larger one, or the smaller one. So this will actually is the same idea than this one. But I personally think V1 is more understandable. So if you come up this version, so it's actually easy for others to understand or digest. But if you come to this one directly, add a further step. So let's check that. Not supported. Let's see. What's so we're not supported between integer and the list. So I see here. So we need to have end equals pi1, right? And so if so here, let's see, if s and e end is p. So here I see p not 1. So this is the first interval. This is the end point. So we have an end. Then here we need to retrieve the s. So now let's check. Yeah, it passes one example. Now if you check the generic case, it will pass. Yeah, it passes all the cases. So I guess that's basically the second comment. So the last comment is that, so we have a playlist on interval merge type problem, or you can, as a practice, you can try this problem, non-overlapping intervals, right? So with that said, I guess that's about it for the current video. Thank you.